Hey, Plumber Tom here. If you're studying from the Mathematics for Plumbers and Pipefitters book, you've come to the right place. I'm glad to help you with your understanding. Don't forget to check in the description below this video for access to books and resources that will help you with your understanding. There are online courses and other things that you can take that will help you prepare for a state test. When you purchase from those links, you're helping me to be able to create more great content. Thanks for watching. Hello and welcome to this presentation of Mathematics for Plumbers and Pipefitters. My name is Thomas Hicken, and in this presentation we are going to go over Unit 2, Formulas. The objectives in this unit are to define and use symbols of mathematics, review math procedure and math precedents, and relate geometry to piping mathematics. Let me say this in easier terms. There are formulas in this chapter that you will need for the rest of your life as a plumber. And we're going to go over them. Largely geometric formulas. But before we get to that, they make this sound really exciting. They really make it sound like a chemistry experiment, like you're making a secret formula. Whoever makes up the formula has the right to assign whatever variable symbols to quantities that he or she wishes. You get to make whatever you want, so long as they are not any of the universally accepted math symbols. However, the maker of the formula, that could be you, must supply this information with the formula. An important rule is that a symbol can only have one meaning in any problem. For example, if you put a K in your problem, then every other K in that problem or equation or formula has to be the same thing, the same number, represent the same value. Don't forget that. And now let me state the absolute obvious. Right here on your screen, I'm going to put an equal sign. Ding! On this side of the equal sign, over here, the values are going to be the exact same as this side of the equation, even if the numbers creating that value are different. Well, come on, it's an equal sign. They take the time to point that out, though. It's always going to be the same in the end, right? Okay. All right, let's play a little game to demonstrate and emphasize the properties of math operators. The question is, if I take a series of numbers and multiply them and then change those numbers around and multiply them, am I going to get the same answer? What if I do that with addition or subtraction or division? Let's see which ones come out the same and which ones don't. You do the math. Ready? Go. Hey, how did you do? Hopefully you can see that when it comes to multiplication and addition, it doesn't really matter what order we do those numbers in. When they're the same numbers, we get the same answer. But with subtraction and division, it matters. The order matters. Now keep that in mind as we move forward through this math book and as we look at formulas. to the power, raise to the power, raise to the power, raise to the power. Whoa, sorry. Bring it back in, Plumber Tom. It's time to focus. Powers and roots. I just wanted to make sure that we're on the same page as far as what powers are. You multiply a number by itself. We write that by taking the number and writing a superscript. That's a little number up to the, I'll be on this side for you. The small superscript number is going to indicate how many times the number was multiplied by itself. So in this book, they give the example of 5 to the 4th power. That's 5 times 5 times 5 times 5. And then I love this. They say, if we suddenly had an urge to know the 4th root of 625, because do you know how many times I sit around and I'm like, oh, I have this urge to know the 4th root of 625. Well, maybe not. But anyway, to go back the other way, we take the root, right? And if it's squared, then we call it square root. That would be just dividing that into what times itself. If it's cubed root, it's what times itself 3 times. But we're breaking it back down the other way. No stress here. Just wanted to make sure that you remember how that all works. When it comes to powers and roots, please use your calculator. As we do formulas, we're going to need to keep in mind certain orders of the way we process these formulas. So let's review a few rules just to make sure we're good to go. Rule number 1, always do the brackets first. They're kind of like a mini problem. Let's do an example. We have in parentheses 3 plus 2, and then that's times 9. So we take that first. 3 plus 2 is 5. We're going to replace that and say 5 times 9. 5 times 9 equals 45. Good? Rule 2, always work from the innermost set of brackets outward. So if we have multiple, we've got parentheses and then brackets. Start with the ones inside, then move outside. So we can see that in the example. We have in brackets and in parentheses 3 plus 2 parentheses times 4 bracket times 9. We're going to replace the parts as we go. 3 plus 2 is 5. So in brackets, now we have 5 times 4 times 9. We multiply those first in the brackets. So that's 20. 20 times 9 is 180. Rule number 3, work from left to right, but do the division and multiplication before the addition and subtraction. They give us this problem. Do this problem. 3 plus 2 times 9. What do you get? Well, again, multiplication first. So 2 times 9 is 18 plus 3. You should get 21. That's where you go. Okay. Rule number 4. Powers of numbers and roots of numbers take precedence over all other operations. That's the first thing you do. And believe you me, we do this a lot as plumbers. So here we go. Example. We have in brackets parentheses 3 plus 2 parentheses times 4 minus 3 squared times 9. So what do we do first? Well, let's focus on the parentheses. 3 plus 2 is 5. So we're going to replace that. Now in the bracket we have 5 times 4 minus 3 squared bracket times 9. Now we're going to do the powers. We get 5 times 4 minus 3 times 3 is 9 bracket times 9. I promise we're making progress. Now we complete the work in the bracket. We're going to get 11 times 9, and then we take that. 11 times 9 is 99. Fifth rule. A long division bar implies the problem grouping in the same manner as brackets. So, example. 124 times 5 over 5 to the 4th power. Well, 124 times 5 is 625. 5 times itself 4 times is 625. 625 over 625 is the same as 1 over 1, and we have 1 is the answer. Okay, keep these rules in mind. Try out these problems next.
Okay guys, keep it going. This is mental push-ups. You just keep going, because your mind's getting stronger as you do these. If you want to do some real push-ups to keep you awake, you can do that too.
All right, good job, guys. You feeling that mental workout? Maybe a little bit of physical workout too? If you had trouble with those, or if you got some of the wrong answers, what I need you to do is go back in the video, rework that, and find out why. This is your chance to improve yourself. But this was a good exercise for us in those order of operations. We're going to be using that sort of thing as we move into the formulas, which let's move into that now. Let's look at some geometric formulas that we're going to use in plumbing throughout the rest of your plumbing education experience. So here we go. We're going to look at each of these shapes, examining the ways that we measure them, whether it's the linear measurement, the area, or the volume. Let's look at the formulas involved with that. I'm going to go kind of quickly through these, and then we're going to do some practice problems, at which point you're going to be on your own and you can do the exercise problems based on the use of these formulas. So let's start with the square. P is the perimeter. S is the letter we're going to use for sides. When you're trying to calculate the perimeter, you take 4 of the sides of the square, so 4 times S is going to give you the perimeter of a square. If we're looking for the area of a square, we're going to take 2 of those sides and multiply them by each other, and that's going to give us a squared area of that square. Another way to write that is S squared, since both of the sides on a square are the same length. Let's move on to a rectangle. A rectangle has 2 sides that are the same, we'll call them length, and 2 sides that are a different length, we'll call them width. To get the perimeter of a rectangle, we're going to add both of the length sides together, as well as both of the width sides together. Another way to write that is P equals 2 times the length plus 2 times the width. Or we can put it in parentheses, P equals 2 times, in parentheses, length plus width. To get the area of a rectangle, we're going to simply multiply length times the width. Let's move on to the circle. A circle has a diameter that's a length from one side of the circle to the other. We'll call that D. Half of that diameter from the center to the outside of the circle is called the radius. If we want to measure the outside measurement, linear measurement of the entire circle, that is called circumference. In order to get the circumference, we need to remember the magic number in dealing with circles is pi. And for our purposes here, we'll call it 3.14. The number goes on quite a bit further than that. To get the circumference, we multiply pi times the diameter. If we want to find the area of a circle, we take pi and times it by the radius squared. Next, let's look at the triangle. This right triangle has 2 sides that are the same length. We deal with this triangle all the time in plumbing. But let's call one side A and the other side B. The diagonal, which is the longer side, we will call C. To get the perimeter of a triangle, we add those together. A plus B plus C equals the perimeter. If we're looking for the area of a triangle, we take the 2 shorter lengths, that would be A and B, multiply them together and divide it by 2. If we were to take this triangle and double it, make it into a square, then the area would just be length times width, or side times side. In this case, a triangle is half of a square or half of a rectangle, so we divide it by 2. That's why we have area equals A times B divided by 2. That same formula applies to other triangles that are not a right triangle. They could have any dimensions or any angles associated, but in this case, if you look at A would be the height of the triangle, and B is the longest length of the triangle. If we want the area, we would take A times B divided by 2, and we get the area. A trapezoid is different because it has a long side, a shorter side, and some angles connecting those. Let's call the long side capital B, the short side lowercase b, and the height of that A. To get the area of a trapezoid, we take, in parentheses, capital B plus lowercase b times A and divide it by 2, and this is going to give us the area of the trapezoid. Alright, let's move on to volume. The volume of a cube is fairly simple. Just take one of those sides and multiply it by itself 3 times. Side times side times side, or side cubed. The volume of a rectangular prism is length times width times height. Let's have a look at a triangular prism. We have the height of the prism is A, one side of those is B, and the depth is H. So A times B times H divided by 2 equals the volume. A trapezoidal prism is similar to the trapezoid area, but in this case we're going to multiply it by the H. So in parentheses, capital B, that's the longer side of the trapezoid, plus lowercase b, that's the shorter side, times A times H, and divide it by 2, we will have our volume. Finally, let's look at the volume of a cylinder. The volume of a cylinder is figured by taking the area of a circle and timesing it by the depth, or h. So volume equals pi times r squared h. Alright guys, we just went through a lot of formulas, and I have a challenge for you. And the challenge is, as you use these formulas and as you continue through your apprenticeship, you need to memorize them. I know, that's a lot. Maybe you have some of them memorized already. But do all you can as you're practicing this to lock them into memory, because you will need to know some of these in order to pass your journeyman state test, and they won't let you bring this book in with you. So if you can lock these in memory, you'll be all the better. Let's do some of the sample problems, and then I'm going to turn you loose on the exercises. Compute the circumference of a round pipe with a diameter of 6.5 inches. Circumference equals pi times the diameter, so we take pi, that's 3.14, and times it by 6.5, because 6.5 inches is the same as 6.5 inches. And we get 20.41 inches is the circumference. Let's do another quick example using centimeters, just to rub in the fact that you don't get to use centimeters. Circumference equals pi times diameter, that's 3.14 times, they say 15.5 centimeters, we get 48.67 centimeters. Next question, compute the area of the trapezoid in the sketch. Look at the sketch. We have a height of 19, a width of 15 on the top, and a width of 20 on the bottom. We'll pull out our formula. A equals, in parentheses, capital B plus lowercase b, parentheses, times A divided by 2. Take the numbers, plug them in. The area equals, in parentheses, 20 plus 15, parentheses, times that by 19 and divide by 2. Let's do the parentheses first. 20 plus 15 equals 35. 35 times 19 and divided by 2 equals 332.5 square inches. Tell you what, I'm going to skip this other centimeter trapezoid example. Sample problem number 3. Compute the volume of a cylinder that is 14 inches in diameter and 20 inches long. The volume of a cylinder is pi times r squared times h. So let's plug that in here. Volume equals 3.14 times 7 times 7 that's our radius squared, times 20. We get a total of 3,077.2 cubic inches. That's how we roll. And now for the time we've been waiting for this whole time. You get to try out these formulas. You've practiced some of the math that will help you to accomplish those formulas. I'm going to turn you loose on your exercises. I would recommend you get a separate piece of paper, write out your work, write out your answers. Good luck on your assignment, and I will see you next time as we continue to study mathematics for plumbers and pipe fitters. I'll see you then.